So Sanborn is a geospatial services company, as Gavin mentioned. Um, we have a number of partners. Um, we do end-to-end services. So we do everything from fly the aerial data to produce the final map. This is a hand-drawn map of the Chicago stockyards back in the 1800s that Sanborn produced. We own our own assets. We won't go through them, but we generally use aerial-based assets, as Gavin said, although we do have some mobile and others. We have a number of aircraft. And we have a number of different types of data that we get from all those. So whatever the requirement is, we can usually meet it with a source of data that the company produces. We also use data from our other partners, Bexel, Hexagon, and others in our production, depending on what the customer needs. So yes, we go back a long time to the Sanborn fire insurance maps. In the very, I would say we were one of the first in cartographic mapping of the United States. And we've done some more current projects, depending on the customer and what they want. And we continue to do a lot of digital mapping from digital sources today, whether that's LIDAR or airborne data or mobile data. We create a number of products. And not too long ago, we mapped the country of Qatar. We built a GIS database for them. We literally mapped everything on the ground that existed. So it's the most complete asset inventory that we had ever done. Every tree, road signs, cable markers, you name it, we mapped it. All their oil field equipment we mapped. So a pretty large project, took us quite a few years to get it done. We flew the imagery ourselves, sent planes and crews and sensors to Qatar. And they're using that database today. And we talk about asset mapping, and most of the time we're talking about LIDAR, and we have both mobile LIDAR and airborne LIDAR. And we've done a number of mobile LIDAR mapping jobs, and I'm not going to go into a lot about mobile LIDAR. You're going to hear some more of it later on in other presentations, and you've heard a little bit already. We integrate, though, the aerial and mobile LIDAR for many of our customers, which gives them a unique data set to take into their CAD models or their other software for analysis. And we do some of the analysis for them. So in this one, we integrated both mobile and airborne LIDAR together. And in TopoDot, we did a significant amount of analytics for one of our customers. This is another example where we were doing some highway work and the interest was in cross slopes. So in that curve you see there, we measured the cross slope at a number of places across the curve from airborne LIDAR. So LIDAR advantages, as already been discussed, it generally results in a savings over traditional survey. All the technologies, whether it's drones or mobile or full-size aerial, collect an enormous amount of data. And that can provide difficulty to some people trying to process it themselves. Hence our investment in a significant infrastructure to do that processing. As people have already mentioned, typically the technology significantly reduces field time. But you have the back office processing. You generally have to have the hardware and software to manage it. And it can provide a cost savings. So it may not be a solution for everything, but it does provide significant benefits, as we found with our customers. But looking at other technologies, Sanborn isn't just focused on LIDAR. We also investigate the best technology for the job we have to do. So a number of years ago, we got into the oblique imaging world and started down the road of collecting counties and cities of oblique imagery. We have a number of oblique imaging sensors. And what we differentiated ourselves with is the accuracy of the oblique data. We developed a processing system not just to aerial triangulate the nadir camera in an oblique system, which has 5 cameras, but all 5 cameras, which enabled us to get significant accuracies out of the oblique imaging data, especially when we're dealing with resolutions like you're looking at on the right-hand side of the slide. That enabled us then to take on some new kinds of projects. One of them, for one of our customers, we mapped an area of Highway 36 here in Colorado, and they wanted literally everything on the highway mapped. So rather than approach it from a mobile LIDAR perspective and imagery, we decided oblique imagery would get us what we needed, and it did. What you're seeing is an overview in the bottom left corner, a 2D view of that project. And being a significant Esri partner, you're seeing Esri 3D view of the same project with all the elements on the highway map, the signs, the poles, the paint stripes, the lanes, everything. And we created an Esri database for the customer of every object that was on that highway. The lanes, the paint stripes, the signs, the barriers, poles. There were bridges. We did the bridge decks and everything else, and created a complete database for them that they could use for the application they had. What we found was the cost to do this was less than our traditional LIDAR approach to do it. We haven't tackled the next one yet, but we have another project coming up of significantly greater length, and we're looking at the trades of how to do it with oblique data versus mobile LIDAR data. So far, the oblique imaging methodology seems to be winning out on cost. The other advantage oblique imagery gives you is you can build 3D meshes out of it. which we typically do with our oblique imaging data. So as 3D has become more and more popular, creating a mesh for a customer that has the photorealistic textures on the buildings and enables the measurement, accurate measurement of the objects within the 3D mesh, can easily be imported into an ESRI software or Bentley software or anybody's 3D software, has proven to be something that more and more people are wanting to have. But we didn't stop with obliques. We decided we would continue down this path and see if we could even come up with a cheaper method of mapping. So we recently developed a stereo camera system, and we drove a section of the highways in Denver to test it. It's a dual camera system with a 90% overlap between the cameras. So we can do photogrammetric processing on the data. Has a Planix GPS IMU. And it did exactly what we wanted it to do. It created beautiful imagery that we're able to process and then locate objects in. Our most recent plan for doing that involves some machine learning that some of our people, our software developers, got involved with and started applying and created a whole new process for us. So this is the top left is an image that you're looking at, taken with the cameras. The middle is automated sign recognition that was run on that image. And the bottom right is an image point cloud that was created from the imagery so that we can measure where exactly each one of those signs is located. So it's still being sorted out, but the system is working as we planned it to. And with a little bit more tweaking, we're going to have even a lower cost approach to mapping the objects that our customers are requesting on the highways. Something else that we do as part of our business is we do emergency response. This is some imagery that was taken during right after Hurricane Harvey in Houston. And we have an application, we load the imagery in, we collect it, process it, and put it on the web within 24 hours of collection. And the application has a swipe tool like many applications do, where you can swipe back and forth and compare old imagery to new imagery, or you compare maps to the imagery and identify what's going on and where you are. Obviously, this highway was flooded. No one had been there yet to block it off. We still had cars in various stages of trying to travel down the thing. You can see one down here floating off. But this is the kind of information that we started working on about 3 years ago as part of our relationship with Vexel and the National Insurance Crime Bureau. And we've continued to enhance it as we move forward. in time and create more web-based services around it. Another application we recently developed was something we call Image Analyst. And here we're flying imagery of highways and corridors and various other right-of-ways with a fairly low-cost camera and a single-engine airplane to keep the costs down. But it allows you to monitor the condition. So here you have a zoomed-out view of a highway. The left-hand side is showing you the flight paths and the positions at which the imagery was taken. And then by literally clicking on that position, the actual image comes up, and you can measure things, you can rotate the image, you can change coloration, you can do a lot of things with the imagery. But zoomed in, you can see that it produces pretty high quality data. So you can look at guardrails and medians and understand what's going on in a highway environment or any kind of right-of-way environment. So Sanborn believes in accuracy. And we also believe in the authenticity of the imagery, making sure the data is correct. And where our experience comes to play is generally in large data collection programs. There's many people that are going to be talking over the next few days that are involved in many different kinds of project sizes. And not to get me wrong, we do small projects also, but most of our work is in fairly large scale programs where large volumes of data have to be processed and processed accurately. And the customer has to be able to rely on the results and the analytics that we provide them coming from the data. So that concludes my presentation. I could take any questions. I don't want to take up a bunch of your time talking about airborne and mobile LIDAR, as you'll hear more and more about it over the next few days. So if you have questions related to what we do, I'd be happy to answer them.
Thank you, John. I kind of have a couple of questions. So you're looking at different kinds of LIDAR. This is a question that came up a little earlier, and I wonder if you would mind talking about it a little bit. The there's the traditional airborne LIDAR that, the sweeping patterns that we've seen for many years. And then there's sort of the one that the Harris Group does.
Geiger mode.
Yeah, the Geiger mode. And then there's the single photon. I don't know if you want to open that can of worms and talk about it, but what are you seeing in contrasting those? Or maybe, yeah.
Well, not only that, but now we just bought 2 terrain mappers from Hexagon. And so that has a rotating prism in it instead of the oscillating mirror.
Oh, okay. Okay.
So I think you have different tools that are good for different things. The single photon and the Geiger mode came out of the DoD world, and was applied to the commercial world, or really they came out of the DoD world to try to win, I think, some of the 3DEP business. And 3DEP being a national program, you're looking for large area collection at lower costs. But what we've seen so far is that the cost really isn't significantly lower when you look at the end-to-end cost of flying those systems. They do cover large areas effectively, but they had materially impacted the cost. And each one, everybody's LIDAR system has unique characteristics. It doesn't matter if it's a Regal system, it doesn't matter if it's a optic system or a hexagon system or a Geiger mode LIDAR or a single photon LIDAR. They all have unique characteristics. And it's about understanding those characteristics and then applying the right tool for the job.
Okay, cool. So we have a question up. What is an estimate of your cost saving with photogrammetry versus LIDAR? And do you use omnidirectional cameras for any of your photogrammetric data collection projects?
We haven't used omnidirectional cameras. The cost savings that we've seen with the photogrammetry-based approach versus mobile LIDAR has been about the photogrammetry-based approach using the oblique imaging is about 60% of the cost of the mobile LIDAR. Now, you don't get everything that you get with mobile LIDAR. So, our requirements to meet those requirements, traditionally, we would have used mobile LIDAR, but because there were some things that customer didn't want necessarily that mobile LIDAR provides, we looked at how could we lower their cost and not give them those things they didn't need. And that's where the oblique imaging came in.
I see. I've seen demonstrations of the combined, LIDAR and photogrammetry, and certain advantages touted.
Very awesome data sets. We put them together all the time, and we have many customers that love that data.
Okay, and I'm liking the data from the oblique systems, because you remember the days when photogrammetry based attempts that buildings look like melted ice cream and things like that.
Oh yeah.
So, it was the things have improved.
No, the processing, you still have to have a significant processing farm to process the 3D data from the oblique imagery, but the quality of the processing has improved significantly, the output quality. No more melted buildings, or we called it no more candles, melted candles.
There you go.
The trees look like trees and not blobs.
Okay.
It's really gotten a lot better.
Well, it was interpreting. We got good at interpreting blobs, sort of like GPR underground scans that look like sonograms. So.
But for things like Dr. Fisher was talking about, LIDAR is the way to go. I mean, his requirements are totally different and couldn't be done with an image-based sensor.
Cool. Right tool for the job. We have a comment and a question from Nimanja B. Thank you for your interesting presentation, ! How is it possible that the last presented system, which includes flight time, is cheaper than stereo cameras on the ground? Thank you in advance for your explanation.
I want to understand the question a little better. Can you repeat that?
Okay. How is it possible that the last presented system, which includes flight time, is somehow cheaper than stereo cameras from the ground?
Area coverage.
Area coverage, yeah.
Yeah, you just cover so much more area. and you don't need as much control. You know, our ground control from mobile-based systems is significant. Um, what we've seen from the airborne systems, and you heard a little bit of it in the Trimble presentation, you know, using these, you know, new capabilities that everybody's put out there, whether it's Hexagon or Trimble, to augment the GPS. All of a sudden, from the airborne, the quality of the airborne GNS systems, you know, just all but eliminates ground control. We don't even run base stations anymore, where we used to run base stations, and we have very minimal control requirements now.
Okay, but you know, in the QA and QC step, you've got to sample in on no.
Oh yeah, you still have to collect some control. You still have to validate that you met the spec.
Okay, well that's the first thing that comes up in any conversations with a surveyor is they, you know, we immediately freak out and go, oh my God, no, you don't just fly it and call it good. No, there's definitely QA QC steps involved. Okay.
Yeah, and you know, and as you know, in the airborne LIDAR, I mean, there's literally, you know, a good sized project, there's hundreds of verification and validation points, and collecting ground control to not only validate it all, but to be able to categorize the LIDAR data properly. So it's an involved process.
Well, another this has come up quite a bit today already about currency, frequency of resampling, reviewing stuff. And I'd been reading a lot more about how those are informed by change detection, you know, can inform how often areas need to be re-imaged or rescanned. And your thoughts on this one? One interesting proposal that I'd kind of talked with someone about was using satellite-based INSAR, you know, the synthetic aperture radar interferometry, for those unfamiliar with that term. I tend to use that a lot for my monitoring work. Using that for change detection to trigger when the mobile system or the airborne system needs to go over an area.
Totally agree. So we've looked at multiple sources. We have a whole, I didn't put it in this presentation, we have a whole 3D change detection process that we run for customers. And depending on what they're looking for in terms of change, you know, we use different systems. So we've used everything from planets, 3-meter data, to the more high resolution capabilities of companies like Maxar and their satellite data, to the SAR companies. We've used their data, and you've got it exactly right on topography. The SAR data, because of the coverage areas they're able to do and the accuracies they're able to achieve with stereo SAR, you know, you can identify change very quickly with those systems, and then go to the field with whatever collection system meets the customer's requirements and update things.
Well, the SAR, you know, it's kind of amazing, and people misunderstand it. It's not a ranging system. It's not giving you something you can build a 3D model from.
Right.
But it's insanely precise at showing a change. You know, 2 millimeters over a year, you can look at that. You know, or if the company's dewatering for a structure and the ground sinks, you can't hide it from SAR. So.
Yep. But then the buildings mess it up, so you got to be careful with where you try to use it.
Yeah, that's true. That's true. The persistent scatterers, and that could be a subject for another virtual conference. But so, what are growth areas in end-use communities for your like imaging?
Well, there's still a large demand for precision aerial survey data from traditional, aerial survey cameras and airplanes. You still have many state programs going on, cities, counties. So that business continues. The and and the resulting products that come from that, whether they be planimetric data sets or other kinds of data sets that customers want. Tax assessment drives a lot of the business we see in the oblique imaging world. The tax assessors, Eagle View and others did a good job penetrating that market and educating the tax assessors on the value of oblique imagery. And we continue to see that market grow and more people adopt oblique imaging. Both Hexagon and Vexel have significant oblique imaging sensors out there now. And so the cost for oblique imaging has come way down because of the area coverage. Quality's gone way up, which is helping generate that 3D mesh quality that we're starting to see and make that usable in various software. So I think you saw probably earlier this year, Hexagon announced a whole world 3D visualization capability at CES. And we're yet to see that take over the world. I think people still kind of treat it as a unique thing when you're talking about 3D, but it's getting there. The satellite guys have their 3D implementations too, and I think we're starting to see more and more of that take hold. And that combination, as you mentioned, the imagery with LIDAR. So when you're collecting both, the quality just goes through the roof and the accuracy goes through the roof. So all of a sudden you have not only very, very precise data from an accuracy standpoint, but it just knocks your socks off as far as the quality goes. So I think that whole 3D market is going to continue to grow. I think we're in the beginning of it. It was a novelty for a long time. It was great to go, okay, yeah, we have some 3D, let's visualize this. But I think that's growing. You're seeing, what this whole conference is about, of right-of-way mapping and, under the federal highway guidelines, all the requirements that they have out there for mapping assets, understanding the condition of assets on the highways, and we're seeing more and more of the application of GIS in the Department of Transportation marketplace. And so therefore, while we traditionally did aerial surveys to support engineering construction in the Department of Transportation marketplace, now we're doing all kinds of other surveys, whether it's mobile LIDAR or asset collection, as was shown earlier. So I think that market's growing. Autonomous cars are going to need all that data. They're going to need to know where the poles are and the stripes are, and what the grade of the highway is, and what the super elevation is, and what the cross section is. So all of that will continue to be more and more in demand as things move forward with autonomy, whether it's autonomous robots delivering packages or autonomous cars driving themselves. Or autonomous taxis, autonomous buses. Most of the autonomous buses running those short routes in some cities, are able to do that as a result of tons of mobile LIDAR scans they did to map that whole environment. So I think our industry is well poised for bigger, better, faster, and more growth.
Definitely. That's what we keep saying. That demand is there and it's going to be unleashed. when the pause button's off. And then you mentioned about autonomous and the assisted and autonomous vehicle market. It's really advanced in the V2V, vehicle to vehicle. That's so much easier to deal with because that's a live relationship.
Mhm.
But the V2X, the vehicle to structure or,
Right.
highway furniture, is the uncertainty of how current is that, how well can it detect it, how can it verify it. Yeah, the more imaging in the LiDAR that can happen, the better on those highway corridors. Otherwise, we would be many, many years away from that. That's for sure.
Yep.
We have another question popped up, and this was from your street level data. How would you compare the accuracy of the point clouds produced from SLAM, simultaneous location and motion, parallax, versus LiDAR?
We're not in the mobile LIDAR range, of millimeters, so to speak. We're in the centimeter range with the camera systems. The question is, what do you really need? How accurate do you have to map the base of that pole to? What is the requirement? So yes, the mobile cameras are going to be a little bit less accurate than the LiDAR, but the cost to provide the data is also magnitudes different. So it's that historical cost quality trade-off. We see those curves all the time.
Definitely. Yeah, we see that. It's sort of like the ante got upped on precision. When we surveying and mapping, things got more and more possible to be precise, but it's got more costly, and there's been a bit of a revolution in fit for purpose.
Right.
Understanding that sweet spot. So yeah, that could be a whole different conference all on its own for judging that. So if
that's
people
why
have
we
questions,
developed some of the stuff we've developed, was trying to fit that customer requirement versus, we knew we could do it with other systems that exist, but then were they willing to pay that cost? What substitute product were they going to go use if we couldn't get our cost window where they needed it to be? And that's the reason for developing those things.
definitely. I had a stakeholder in a big civil project saying, "Oh, wait a minute, Google Earth has 3D." I'm like, okay, into that conversation. So anyhow, hey, thanks so much for joining us today, John. If people have questions for you, that they can, or your company, they can go to the page in the guide and book meetings.
That's right.
So, cool.
And thank you for doing this, Gavin.